So when you're talking about concrete, it's a versatile material. Fiber, when it is mixed, it is very easy to mix. That way we have to design a concrete. Then strong and durable, it does not rust because concrete is not much having issues. Issues is basically with the your reinforcement. Concrete itself is not having issue. If you make plain concrete, it will not last for long more than the RCC structure. But the issue is basically your RCC structures. And in real sense, it does not need any coating. Since now your uh, vehicle pollution has increased, so CO2 has increased, so you need some coating for avoid the carbonation, to reduce the carbonation. But in real sense, concrete doesn't need any coating if you make proper design. Impermeable concrete, it's also fire resist concrete because it can hold about 300-350 degree very easily for short time, and then it is start deteriorating the paste of the concrete, bond between aggregate and your paste. So this is a unique features in the concrete that you can utilize and get a good concrete. What is the constituent concrete? It's a mixture of aggregates and paste. It's very easy to understand. It's the only ingredients which is aggregates, you can say. This is around the volume about 60 to 70% of volume only in the aggregate, and they are inert in nature. Around 90%, 99% aggregates are inert. They are not taking part in any reaction to develop the strength in concrete. That one has to understand. But they are very, very not in reactive, but responsible for getting workability of the concrete, pumpability of the concrete, and finishing of the concrete. Now you say paste is also varies maybe 30% to 40% by volume. Why I written volume? Because you make the concrete, you weigh the aggregates, whatever batch you are saying maybe per cubic meter, but ultimately when you sell the concrete with RMC, you are selling by volume. So whatever you have weighed, your volume has to match. In 1 cubic meter, there is around 1000 liters, has to be matched. So those details we'll discuss during our mix design. But you understand now, you can see here in the paste, Portland cement or binder. Now the trend has changed. Earlier only we are using OPC, but now we are using OPC plus other cementitious, supplementary cementitious material. That's why I called it a binder. Means what are the binders? We'll come into that. So only with OPC we rarely make a concrete unless there is a site mix, small quantity concrete is there. But otherwise it is advisable to go with the OPC plus fly ash, GGBS, metakaolin, silica fume, microsilica. A lot of things are there available in the market today. They are basically act as a performance enhancer to get the very good concrete about this. Though the base is only Portland cement, then water definitely is varies. Then also now one of the ingredient is your admixture. There are two types of admixture. One is chemical, one is mineral. So mineral come in the binder, but chemical also admixture also is a part of concrete. Around 99% concrete we use, everywhere we use only admixture. You take the scenario maybe 20 years back, we rarely use these admixtures. But today it is the way the requirements has come for the structures, placing requirement, transportation requirement. So admixture is must, definitely. Without that, it's very difficult to make a concrete of desired workability and strength and finishing. You see the cost. proportion of the cost. Binder maybe around 10-15%, but that is the governs the major cost. About 60% cost goes only with the your binder content. That's why we are always saying whatever mix you are doing, whatever concrete you are producing at site, and based on your test results, one has to go on optimize the mix designs. So when you start with mix design at particular proportions, as your results come, as your quality control is very good, you can go on optimizing the mixes and reduce the cost of the concrete. That is always possible. But we rarely do the analysis of test results at site and then we go for the optimization process. But it is a continuous process. One mix design given for particular project, they are using for last 2-3 years, 4 years, though they are getting very good high results. That is not the role of technology, concrete technology. Concrete technology's role is he has to optimize the whole process and optimize the cost also. Once his quality control is very good, definitely he is able to achieve the better concrete. Then fine aggregate and coarse aggregate, you can see, though they are very high, but the cost wise it is less. So major cost goes only in the your cement or binder. So there is a huge scope to optimize the cost. So even RMC also giving you the mix. And once you get those results at site, you analyze the results, maybe first 30 results, find out the standard deviation, and then you start optimizing that mix also. Then it will go as a prescribed mix. One is RMC has given, and then you can have a, based on the data, you can have your own mix as per your requirements. As I said, strength definitely is a requirement for the concrete. But earlier, maybe in 90s, people are made the concrete with the desired level of strength, but there is a drop. Definitely there is a deterioration of the structures also. So then strength has taken the second role, and then first will come with the durability. So if you remember our code from 1973, 1978, IS 456, that is our Bible for concrete, code of practice, and that has revised in 2000, year 2000, and that if you read that code and compare the code in 1978 to 2000, there's huge changes they have made in this, and everything is goes towards the durability of your concrete. Durability of your concrete. So what is the durability? How to test it? Those tests are now already, it is there in the code now. I'll share with you once in subsequent lectures. Once you maintain those parameters, whatever mentioned in the code, you are definitely you are able to achieve the strength also. So our code is also based on such requirement of, because there's this, because we have seen that once you having the strength, your structures also giving away within 3 to 4 years started cracking. The strength was okay because our cement strength has increased. We have moved from 33 grade to 53 grade. So with the same cement content, we will get very good strength. But what happens to water binder ratio? What happened to the porosity of the concrete? Though porous concrete have given the strength, but durability, yes, there's a question mark. So how to test durability? There is a certain test specified. Some of the test has recently introduced in maybe 2018 or 2019. But international tests were there when I said earlier, we are working for the JJ flyover in 1998, those tests were specified. Not only the strength M75, but there is a test also for RCPT, rapid chloride penetration test. Then water permeability as per DIN standard, German standard was there that time, and RCPT as per American standard. Then we have ISAT, initial surface absorption test, that is as per British standard. So those tests are mandatory to go in the structure, both when when you design a concrete as well as in situ concrete also. Now, looking at both the parameters, durability aspect, one has to also see the economics. So it is always possible. There's a huge scope for the concrete technologies to economize my mix. As I said earlier, whatever concrete you are making, except your cement and admixture, all other locally available material we have to use. I cannot get idle material from various sources. So whatever available material, maybe you have to search various quarries to get. In JJ Flower, we used to search about 6 months to get a good aggregate. Whatever nearby aggregate, what was happening is once you reach that particular layer, concrete is cracking. Means your aggregate itself is a breaking because they are not able to sustain that stress. So you should have very good high strength material should be there. So that definitely that exercise has to be done regularly. Then you can have very good proper concrete. Because getting a strength only adding cement is not the solution. When you are working with concrete, one has to understand a thumb rule is use minimum cement and use minimum water. That will give you best concrete. Minimum in the sense I am saying optimized. And you will surprised to see some of the optimized mixes are far better performance in durability, where they are given very high cement content and giving very bad durability and also economics. So utilizing of your supplementary cementitious material is also a major role to understand the and use in concrete. What is durability? Is the ability to resist weathering action, chemical attack, abrasion, maybe for road or factory floor, and any other process of deterioration. The durable concrete will retain its original form, quality, and serviceability when it is exposed to its environment. So if you see IS 456, they are given exposure conditions. 5 exposures conditions they are given, and accordingly, they are given minimum cement content, maximum water cement ratio, and minimum grade. See, minimum grade is also specified for the particular exposure that we rarely follow. Especially in Mumbai, people are following, but if you get the rest of the country, they are not following. Till today, they only do the M20 or M25. In Mumbai, minimum grade is for the exposure M30. We are not supposed to use less than M30 for RCC structures. So you are satisfying your design criteria. For that, you may need M25 is sufficient, or M20 also for sufficient. For looking at the durability, you must use minimum grade M30, which is specified in code. So all design engineers for RCC consultant, they have to take note of this, and then you have to go. So concrete technology's role, what is the how you interpret the codes and implement at site to get benefit to your structures. So physical actions, mechanical, load, abrasion, erosion, maybe for dams, there the erosion is there, factory floors, environmental changes, changes in humidity levels, right from 30% to 95%. Now in monsoon, you get 95% humidity. Now your concrete is porous, then definitely moisture will absorb and slowly move towards your reinforcement. And or your reinforcement is protected for only 20-25 mm cover zone. And that cover zone is not properly maintained. Definitely your structure will show deterioration at early ages. Though your core is very good, but your cover zone is very bad, then we'll have a lot of issues. Extreme temperatures. Anyway, we are lucky in Mumbai that we don't get extreme temperatures. But if you go to the Delhi, you get right from 10 degree to 50 degree. That much variation is there in the temperature throughout the year. Winter may go with a 4-5 degree also. and in summer may go about 45, 48, 50 degrees. That thermal shock, concrete has to stand. So accordingly, we have to design. Who will take the shape? Only in the concrete. Then chemical actions also there. Internal, alkali aggregate, delayed integrant formation, gypsum formation. These are there. Technical terms are there. I don't go into much detail about this. Those are interested, they can read it this. But at least you should know what is happening, because most of the aggregate are non-reactive, but few aggregates are reactive, and they are reacting with your alkalis in cement. I'm getting alkali silica reaction. That is a forming a issue. Delayed integrand also similar. You get calcium sulfoaluminate, it absorbs water and then it swells and disturb your concrete. So before using any fresh material from quarries, you must go through all the test procedures, test it, and when it is meeting the requirement, then only you can go for use in concrete production. External carbonation, as I said, your all vehicle traffic or industrial CO2 reacting with your cement and your carbonation takes place. Sulfate attack, maybe your soil contains sulfates, lot of sulfates, because we are near to the sea, and sea has also got the chlorides, and chlorides are basically responsible for corrosion of steel. That's why I written corrosion. Sulfate also, sulfates and alkali aluminates, they react and form a calcium sulfoaluminate. It has got deteriorate the concrete. So we have to use low alkali, low C3A cement for the sulfate. So better you can use some supplementary cementous material to have a taking resistance to both sulfate as well as chlorides.